Hi, Assalamualaikum. My name is Irfan bin Abdul Muttalib and my metric number is DF200066. We are from Group 4 for Geology Engineering in Section 7 and our project is about earthquake in Sabah. So, first of all, as we know, earthquakes are usually caused when the rock underground suddenly breaks along the fault. This sudden movement will create an energy that causes the seismic wave that make the ground move. As you can see in figure 1, shows the 4 types of fault, which is A is the normal fault, B reverse fault, C lateral fault, and D oblique slip fault. So, for normal fault is when a horizontal tension force is applied to the ground. One side of the layer moves downwards compared to the others. For the inverse fault, the ground was compressed and one side of the layer shifted to higher in relative to the other. And lateral fault is when the ground subjected to horizontal shear force and horizontal movement along the fault plane. And lastly, the oblique slip fault moves the ground ups and downs. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Nurul Haryani Afrida binti Muhammad Arifin, number metric DF200156. Okay, I will explain about the literature review regarding the earthquake at Sabah. About the literature review, the MW 6.0 MT Kinabalu earthquake of 2050 was a totally deadly surprise because it occurred far away from the nearest plate boundary in a location with relatively low. Its unilateral failure occurred almost exactly beneath the 4,000 meter height at the Kinabalu, causing widespread slope failure and rockfall that killed 80 hikers. According to our seismological and morphotectonic investigation, the rupture occurred on a normal fault that is placed upward of the previously reported normal, which is Maracau fault. Our mapping of tectonic landforms revealed that these faults are part of 200 kilometers long system of normal fault. Tectonic reasons for this active normal fault system is unknown, and the length of the longest fault segment indicate that it is capable of producing magnitude 7 earthquake. Given the previously undetectable geodetic rates of active tectonics, deformation across the region, and such large earthquake must occur only infrequently. Okay, about this Map A and Map B, earthquake at Sabah occurred on 4 June 2050 at 11:50 UTC, and the local depth of the main shock was between 6 and 18 km on a normal fault striking nearly north and south. And prior to the occurrence, the largest recorded earthquake were an MB 5.0 in 1991 at figure 2B, and which caused minor damage in the runout area south of MT Kinabalu. Okay, at figure 2B, the Mount Kinabalu main shock causes intense ground shaking in the vicinity of Ranau town, particularly in the area between the town of Mount Kinabalu summit. It is also caused extensive landslide on Mountain Kinabalu, steep slope, including rockfall that killed 80 people and injured at least 21 more along climbing trails on the mountain face. So, the Mountain Kinabalu with 6.0 event provide a once-in-the-lifetime opportunity to improve our understanding of East Malaysia's seismic hazards and tectonic context. We use seismology aftershock, relocation, space-based geodesy, and tectonic geomorphology to better understand the earthquake, place it in active tectonic contact, and map the extensive landside of Mount Kinabalu. Okay, that's all from me. Thank you.
Okay, my name is Muhammad Farisadi bin Muhammad Syarul Zaman. Today I will explain about the methodology of this project. For the methodology, the application that we choose is GIS, that stands for Geographic Information System. Its function is to observe the possibility of earthquake risk in the specific places. It also is a system that can capturing, storing, analyzing and managing geographical data about the land that may be utilized to make plans and choice. Besides, it can determine the threat index qualitative. The disaster threat index is based on two components. The first one, two primary components. The first one is probability of a danger occurring and its frequency. The second one is the substantial effect that has been documented in the disaster. And then GIS has a treatment that can detect the area or place that has hazard exists. It has primary inputs to conclude seismic danger maps. It has three primary inputs the first one is the frequency of earthquakes in nearby locations. The second one is small and big earthquakes are distributed in magnitude. The third one is the intensity of ground shaking is in relation to the earthquake's distance and magnitude. GIS also has benefits that are analyzed, evaluate, and it can also display data in the simple way and in geographic format. That's all for the methodology. Thank you.
Hi, Assalamualaikum. My name is Muhammad Alif Hosnai. I'm going to explain about result and discussion. First, tectonic implication. As a massive landslide, the sea has collapsed due to gravitational collapse. Second, the Crocker fault system might theoretically be the extensional headscarp of the massive landslide as shown in figure 1a, which is gravitational driven model. Third, convert upward thrust fault that is producing the offshore fold and thrust back further up deep, which is in figure 1d, which means basement involves shortening model. And lastly, another theory is that the earthquake was induced by localized strain caused by the 4,000 meter high of Mount Kinabalu, topographic prominence above the surrounding environment, as shown in figure 1c, which is localized stress model. Next, for the impact on Earth's movement. Physical damage to infrastructure were caused by vertical and lateral surface movement caused by the main shock, which is peak ground acceleration, up to 14% of gravity value. Second, around Ranau and Kundasang, public and private buildings were damaged. For several days, Kundasang and Ranau were without water due to broken pipeline. Next, for the impact of rockfall and landslide. Rockfall and landslide cause considerable damage to public and private structure as a result of earthquake. Second, rockfall and landslide wreak havoc on the Kinabalu Park amenities, which is hotel and climbing trail near Mount Kinabalu Summit. As shown in figure 2. Figure 2, which is destroyed hostels, which is center of the picture, due to rockfall at Panalaban near the Mount Kinabalu Summit. Last but not least, impact of liquefaction. In the Pering hot spring area, the tremor produced minor liquefaction. As a result of the mud discharge, the hot water coming from underground turned black. The tremor appeared to have removed silt and dirt locked inside fissures of rock, allowing more hot water to pour out from beneath the surface. And lastly, one of the beneficial effects of earthquake was that is revitalize the aging of hot spring. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Dana Izzuan bin Ahmad Fairuz. My matrix number is DF200087. Now I'm gonna present about the conclusion. As a conclusion, the study has shown that the Mount Kinabalu earthquake is due to the rupture of a blind northwest dipping normal fault that likely separated upward from the Maracau fault on Ranau Valley, which passed the surface on the east side. Besides, the map from the satellite show the area affected by the landslide is more than 225 km square and may be as massive as 500 km square. Furthermore, the geomorphological analysis indicates that the fault that caused the Mount Kinabalu earthquake is part of the 200 km long Crocker fault system. That's all from me. Thank you.